Welcome back to the final lesson of this unit. We conclude Lesson 3 of Section 4, examining both experimental and theoretical probabilities in situations with two independent events. Always remember, if experimental results differ from those expected, it does not mean you are wrong. It is what it is. Let's revisit the following example. A quarter is flipped once, and then a second quarter is flipped. What is the theoretical probability of flipping two heads in a row? If you recall, when we did this in a previous video, the probability of flipping two heads was 1 out of 4. We had created the sample space, looked at the favorable outcomes, which would be H and H, compared to the total number of outcomes, which would be 4. If 20 trials were carried out, how many times would we expect to get two heads in a row? We are considering the theoretical probability here if we were to conduct 20 trials. The probability of 1/4 tells us we would expect to get heads and heads a quarter of the time. If we have 20 trials, 1/4 of 20 would be 5. We've also looked at this by creating an equivalent fraction. 1 over 4 would be the same thing as 5 out of 20. Bottom line, we would expect to get heads followed by another heads 5 times in 20 trials. That's the theoretical probability. What if we conduct the experiment? What will be the experimental probability of flipping two heads in a row if we conduct 20 trials? You knew what was coming. Let's try it. 20 trials. Here is our table to record our results, and we will do a tally for all of the possible outcomes, though our main interest, of course, is on the probability, the experimental probability of tossing two heads. Remember, in choosing whether or not we have heads or tails, we will choose whatever face of the coin we can see on the screen. Here we go. Heads. 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 Tails. Heads. 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 Tails. 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 Heads. Heads. Tails. Tails. Heads. 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 Halfway there, folks. Heads. 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 Tails. Heads. Heads. Tails. Heads. Tails. Heads. Heads. Tails. Heads. heads, 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 tails, heads, tails, heads. And we have 20 trials complete. Let's figure out the experimental probabilities here now. Each of these would be out of 20 because we have 20 trials. We're going to write these experimental probabilities as fractions. For heads and heads, we have 7. For heads and tails, 5. Tails and heads, 6. And 2 tails, 2. Compare those to our theoretical probabilities, which would have been a 5 out of 20 for each of them. In tossing 2 heads, we see that our experimental probability was slightly greater than the theoretical. For heads and tails, they worked out to be the same. For tails and heads, the experimental was slightly larger than the theoretical, and for the tails and tails, the experimental was a bit less than the theoretical. No incorrect answers here, of course. As I've said before, it is what it is. I would encourage you to conduct this experiment on your own. And remember, the more trials you carry out, it has been proven that your experimental probability will approach that of the theoretical. Have fun! I would like you to now proceed to the next video in this lesson.